Well, that's why I made them up for you, because it's going to go really quickly now. So it's all good. So 4.3a, a non-linear function. If you remember on, what was that, Thursday? We talked about linear functions. Do you remember what a linear function is?
Yes.
It makes a, what?
Yeah.
A line, right? Like a straight line, a linear function. Okay, so a non-linear function, the graph is not a line or part of a line. So you're just going to put a big fat not in here. It is not a line or a part of a line. So I'm just going to give you 6 graphs right now, 3 of which are linear, 3 of which are non-linear. And we're going to be dealing with both today, but focusing more on like the non-linear side of things, okay? But there is some comparison between the two. So for your linear graphs, okay, one example of a linear graph would be something like this. You just get a straight line, arrows on both sides, meaning it keeps going. That is a linear graph, okay? What?
Maybe like this one?
It can be that way, yeah. Actually, that's one of my examples. Another example of a linear graph would be this. Notice there's no line drawn in, but those points are making a line, okay? So that is a linear graph also. And then the last example that I'm going to give you is a horizontal line. Okay, so those would all be linear functions. The nonlinear, yeah.
Can the horizontal line be on the line?
On the axis, like here? Yeah. Mm-hmm.
Can it be like this one too?
Well, vertical isn't a function then. So if it's a vertical line, it's not a function anymore. Because remember we said you can't have an x value that has 2 different y values for a function, right? Function can go this way. We'll talk more about that. We didn't do the vertical line test yet, did we, in here? No. We talk more about that very soon. But yeah, vertical is not going to be a function because you have an x value that has all kinds of different y values, and you can't have that, okay? It's a good question, though. Okay, so the non-linear then. Non-linear functions might look like this. Does anyone know what this shape is called? It's a U-shaped curve. It's called the parabola, okay? A parabola is not a linear function. A parabola is going to be like y equals x squared plus 1. It's not x plus 1 anymore. It's x squared plus 1, okay? That is non-linear. Another example of a non-linear function would look like this. It is not forming a straight line, so it is a non-linear function, okay? Still a function, but non-linear, okay?
It's a non-linear.
Uh-huh, yep. That example in your last quiz would have been a non-linear. Yes, ma'am.
Oh, I'm not.
Oh, I thought you were raising your hand. Okay, last example. You will have, more of like a V shape. Okay, that's an absolute value problem, would look like that. Yes, you have 2 straight lines, but it is not a straight line, right? So that's considered a non-linear function. Any questions on those 6?
No.
Okay. Okay. Example 1 here. There are a lot of words going on. Don't let the words freak you out, okay? I'm going to explain to you what it all means, but I want you to see what's going on. So here's what it says. The area A, okay, so A is the area in square inches of a pizza, is a function of its radius r in inches. So you have the cost, C, in dollars of the sauce for pizza is a function of weight W in ounces of sauce used. So it's 2 different things going on. One of these is going to be linear. One of them is not going to be linear. And we're going to figure out which is which by graphing it. Okay? Now, here's the thing. You notice this on your quiz. When you graph something, you have to be specific. You have to tell me what does the x-axis represent, what does the y-axis represent, and give me some numbers to count by. okay? So let's just look at this first one. This radius, is that going to be my x or my y?
X.
It's your x. So we're going to put that down here, your radius. Okay? So then the area is going to be my y. That's going to go over here. And now you need to know what to count by. What would you count by on the radii?
2.
You can count by 2s, or you could count by 1s, right? Because it goes to 10, and there are 10 marks on this graph that we already have. I would probably do that because it just spaces it out a little more. It's a little easier to see. So I would count by 1s, but I'm just going to put the every 2 in. So 2, 4, 6, 8, and 10. Okay, that way you have a little more room to work with. It's not wrong if you do it the other way. If you want to do it just counting by 2s on each bar, you totally can. It's just going to look slightly different, but that's okay. Okay, then the area. Look at your areas here. We start as low as 12.57, and we go as high as 314. So is it going to make sense to count by 1s? No, not even close, right? So you got to ask yourself, what would make sense here? What's a good number to count by? And there's not a right answer. There are plenty of wrong answers, but there's not a right answer, okay? You can count by something different than your neighbor and still get the right answer. Meleon.
By 10.
Count by 10. Okay, so let's think about this. If we count by 10, it would be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Is that going to work?
No.
No, why not? We got to get to 300, right? And we only got to 110. Okay, let's try 50 then. Get these guys out of here. Okay, so if we count by 50, this would be 50, 100, 150, 200, 250, 300, 350. We wouldn't have to go any higher than that. Will that work?
No.
It'll work. You might not have like perfectly exact answers, but it will totally work, right? The thing is, it's going to be really hard to get this perfectly exact. You could count by, let's see, you could count by 30, 60, 90, 120. You can count by 30s and you'll end up with your 300 up here somewhere. So that would be fine too. Let's just go with 50. You don't need like exact. We want to just see the basic curve of our graph. Yeah. So that's the thing. You're not going to graph it on the line, right? You're going to graph it. Let's just do this. Let's do the first one. So your number is 2, 12.57. So you move over to 2, and you go up 12.57. Well, think about that. Our first step is to 50. We can't go that high. We need to go to 12. Half of 50 is what? 25. 12 is still half of that. So we're only going like a quarter of the way up. Okay, so it's going to be right about, oops, not there. Sorry, there. I did it on 1 instead of 2. Okay, so that'd be our first point. So then we go to 4, and this one's nice because it's right at 50. So we'll go 450 is going to be just barely above the 50. Then 6 goes to 113. So from 6, move over 6, up 113. We're going to be toward the bottom of that one. Again, doesn't have to be perfect. 8 is 201, another nice number since we have the 200. So that's going to go right there. And then 10 is at 314. So 10, 314 will be about there. Okay? Notice it's not a straight line. It's got a curve to it, right? It's going to just keep curving the more numbers we would go. Questions on that? So is that a linear function?
No.
No, it's nonlinear. Okay? This would be a nonlinear function. So that's part of what they're asking you. It says, is it linear or nonlinear? You would say this is nonlinear. Okay? Okay. Let's look at the next one. This set of numbers goes from the weight to the cost. What would you count by on your x? What does your x represent right now?
Weight.
Weight. So you're going to put that here. Okay, this is weight. What would you count by? You can count by 2s or you can count by 1s. I'm going to count by 1s again just to give it more space, but I'm only going to mark every 2. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, technically. Then over here is going to be our cost. And our cost is going to go up to $4. What would you count by with that? Hey, Kate, will you wait until after the lesson and then you can go? Or is it like you need to go right now? You're okay? Okay. What would you count by? You count by 1. You can do $1, $2, $3, $4. What else could you count by? What? By 80 cents. You can count by 80 cents. 80 cents, $1.60. Oh goodness, $2.40. You keep working your way up by 80 cents. I would probably count by 50 cents right here. You don't have to, but I just think 50 cents is an easy number to work with, and it will space it out a little more. So I'm not going to write every 50 cents in. I'm going to just do every second one is $1. So this would be, right, this first one would be 50 cents, then $1. This would be $1.50. This would be $2. This would be $2.50, $3, $3.50, $4, and that's as high as we need to go. So you can just stop right there. Okay. So then we need to plot our points. So 2 ounces costs 80 cents. So if you go 2 and up to 80, remember this one's 50 cents. So from 50 to 80, are we going to be closer to the 50 or the dollar? Closer to the dollar for 80 cents. I said that funny. So that's going to be like here. Okay. Then for 4, it's going to be 160, which is going to be just above the 150 mark. 6 is at 240, so you go over to 6 up to 240. That's going to be just below the 250 mark. 8 is 320, so 8 and then 320 is going to be right around there somewhere. And then 10 is $4. Linear or nonlinear? That's linear. That's making a straight line. Okay, so this is linear. Okay, questions on that? Okay, over halfway there. Next one. And last one, really. This one you have to do a little extra work with because you have to fill out the chart. Okay, but it's very doable because you're going to see a pattern happening with this. So it says the table shows the number of blocks in each figure as a function of the number of blocks on one edge of the figure. What pattern can you use to complete the table? So if you look at this, on the edge, you have 1 block, right? They're saying right here, it's 1 block wide, okay? How many total blocks do you see there? 1. So that's this, 1 and 1 gives you this point, 1, 1. Okay? Then you look at this one. How many blocks are there on one edge of that figure? 2. That's this. But how many total blocks are in the figure? 8, right? You have the 4 on the front and then the 4 that are on the back. So you have 8 total blocks, which gives you the number 2, 8. Okay, that's the point on our graph. Okay, so now look at this next one. How many blocks do you have on your edge?
3.
It's 3. Okay, how many total blocks are there?
18.
No.
18.
Let's look at just the front, okay? There's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's all of these. There's 9 blocks there. Okay? Which means if we take one slice behind that, how many blocks are in that next vertical slice? 9 again. So that's 18. Then 9 more. 27, right? So this is 9, then 18, then 27. So there are 27 blocks there, which is going to give you the point 3, 27. Okay, so at this point, you should be able to see that there is a pattern happening. This pattern's a little bit tricky. In fact, I don't really expect any of you to come up with this one on your own accord, but in the future, you're going to see this one more, and you should be able to see this pattern forming from here on out, okay? So I don't expect you to come up with it right now, but if you do, kudos to you. I'll give you a candy. Can anyone tell me, here's what you're asking yourself. What did I do to 1 to get 1? What did I do to 2 to get 8? What did I do to 3 to get 27? And you're doing the same thing. So you can't say I'm multiplying by 4 because that doesn't work from 3 to 27. And you can't say I'm adding 6 because that doesn't work from 3 to 27.
Is it
The little number on top, what number on top?
I don't remember what it's called.
What number is it?
But for 1 it would be 1, for 2, 2, for 3, 3.
No, but you're on the right track. She's close. Does anyone see it? Is it what? No, but you're even closer now. It's not squared, it's... No, cubed. It's cubed. Look at this. Okay, so if I take 1 and I cube it, what do I get? 1 times 1 times 1 is 1. If I take 2 and I cube it, that's 2 times 2 times 2, which is 8. If I take 3 and I cube it, 3 times 3 is 9, times 3 is 27. So I get this. Okay, so if we finish this chart, 4 and 5, anyone know what 4 times 4 times 4 is? I don't expect you to know that off the top of your head. 64. Is that what you said?
No, I said 16.
Oh, gotcha. Well, it sounded like 64. And then 5. Anyone know this one? This one's maybe a little more likely that you know it. 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is?
35.
125. So 5, 125. Okay? So here's what we're doing. We're going to put this into words, into an equation, and into a graph. Okay? The equation is probably the easiest part of this once you figure it out. Well, the graph probably is easier. But this is y equals your x value to the third power, right? Whatever is in that x column, we're cubing it, and we're getting our y. So y equals x to the third power. You're going to see this equation several other times from here. So look at these numbers and think, oh yeah, those look familiar. 1, 8, 27, 64, 125. If you get those, you are cubing, okay, to the third power. Okay, in words, we would just say the total number of cubes is the number of cubes on an edge cubed, right, to the third power. Okay, coming up with a graph. Do you think this is going to be linear? Do you think it's going to form a straight line?
No.
It's not. When it jumps up, we call this exponentially. When there's an exponent, it's never a straight line. Okay, so just keep that in mind. When you see an equation that looks like this with an exponent, your graph shouldn't be a straight line. Let's lay it out. What is our label going to be right here? Edges. Okay, what's our label over here going to be? This will be your total number of cubes. Sorry, that's kind of messy. Okay, what do you want to count by on the edges? I'd count by ones, yep. So 1, 2, 3, 4, 5, and that's as high as we need to go. And then your other side, we need to go as low as 1, as high as 125. What do you think? 5s? So if we go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55 isn't going to quite get us there. So 10s, we can try 10s. So if we count by tens, this would be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. If you're that close, I'm fine if you go 120, 130 for, just add those bars in, that's fine. That's really messy though. We won't need those anyway, but you can do it that way. Or you could just count by 15 instead, or count by 20, okay? Since we wrote all the tens in, we'll just go with tens here. So our first one, we're gonna plot at 1, 1, right? So that's not gonna be very high up on this first little mark here. 1, 1. Then we have 2, 8. So again, we're not even to our 10 yet. That would be there. But then we jump up, 327. So 327 is going to be more like here. And then 464 is going to be kind of halfway between 60 and 70. And then 5 is 125. So on the 5 here, right, this was 110, this would be 120, this would be 130. So we're going to go halfway between on that one, which means our graph looks like that. Is that linear? No, this would be nonlinear. Doesn't make a straight line, okay? And like I said, if it has a squared in it, not going to be a straight line, okay? Questions?